Okay, last little bit. Let's just do a few examples. So let's try adding up using Gauss's method and finding the sum of the first 20 terms, or S20, of the following pattern. So 8 plus 11 plus 14 plus 17. Now Gauss already had an advantage that we don't have. He knew where the pattern stopped. He knew what the last number was, so he could add the first number to the last number. And we don't know that yet. So what we actually have to do is we have to start by finding the last number. In this case, I'm adding up 20 numbers, so I need to find T20 to find the 20th digit. And this, again, is an arithmetic pattern, so I'm just going to use my arithmetic formula. So my first digit is 8 plus n minus 1, so 19 in this case, times d, the amount that I'm adding every time, which is 3. And when I actually add this up, I get that T20 is equal to 65. So now let's use Gauss's method to add up those first 20 terms. So 8 plus 11 plus 14 plus blah, 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 plus 65. So we are going to pair up the first number and the last number and add them together. So these add up to 73. 11 plus whatever's here is also going to add up to 73. And how many times am I going to have 73? I'm going to have 73 10 times because there's 20 terms in total and they're all being paired up. And so, therefore, S20 is equal to 730, or 73 10 times. Let's generalize this and make this into a formula. And there's two ways that we can approach this. The first way is to really embrace Gauss's method. So we're taking the first term, T1, we're adding it to the last term, Tn, and then we're taking the number of terms in total and dividing by 2. The second way can be a bit of a time saver, and it's this idea that we don't always know what the last term is. We don't always know the numerical value of Tn, but we do also have a Tn formula. Because we know, if I were to take this all over again, we know that Tn is equal to a plus n minus 1 times d. Not pi, what am I doing? N over 2. And so we can sort of pre-sub, I'll just color code this, we can pre-sub in our Tn formula if we would like. T1 can also be represented with the letter A. So we can say that this is actually A plus n minus 1 times d times n over 2. Or 2A plus n minus 1 times d times n over 2. And actually, the traditional way that this formula is written, which is the way that I'm going to write it over here at the side, is we write the n over 2 first. So n divided by 2 times 2a plus n minus 1 times d. And this is the most common way that you'll see your arithmetic sequence or arithmetic series formula represented. Now, last one. We can also add up the terms in a geometric sequence. And if I wasn't doing this on video, I would show you how to do it. For the sake of what we're doing right now, I'm just going to provide the formula for you. But remind me in class when I'm back, and I will show you where this formula comes from. Okay. So, I don't know why I left so much space for this one. Our geometric series formula is that Sn is equal to A times r to the power of n minus 1 over r minus 1. And so the only things you really have to be careful with here are your brackets. You do have to make sure if you're typing this into your calculator that the r minus 1 in the denominator is bracketed, because otherwise you'll be dividing by r and then subtracting 1. So let's just try this example. So if we wanted to find S8 for the series that begins 2, negative 6, positive 18, etc., let's start by just double checking we know all of our things. So we know that A is the first term, A in this case is 2. R is the amount I'm multiplying by each time, so to get from 2 to negative 6 or from negative 6 to 18 times by negative 3. And I need the 8th term, so n is equal to 8. So S8 is going to be equal to 2 times r, which is negative 3. Put that in brackets, to the power of 8 minus 1, close bracket, over negative 3 minus 1. And I'm going to highly suggest that everybody pause the video right here and actually type this into your calculator yourself. It's not hard to use the formula, but people do make mistakes when it comes to typing it into your calculator. I'm going to type it into my own calculator right now. So double check that you've got this and that you've typed it in correctly. It's funny, I told you to pause the video, and yet this is taking me forever. Okay. Got it. Negative 3,280 is my answer. And stop and think about if this answer makes sense. I think it does, because if we think about the fact that we have a positive number, then a negative number, then a positive number, then a negative number, and they're getting bigger as we go, and I have 8 numbers in total, that means the 8th number is going to be negative, and it's also going to be the biggest number. So the fact that I have a fairly big negative answer is probably correct. Okay, that's it for today's lesson. Please go ahead and try the homework. The content isn't hard, but I do think getting practice with it is the best way to feel confident. And so there's a few pages of homework questions for you to try now. Okay, see you later.